Okay, so this is just a reminder. This is what we went through last lesson. We talked about what an annuity was, referenced the recurrence relation, which we're going to go through in a moment in terms of worked example. The annuities formula, again, we're going to go through as an example. What the terms mean down the side here, and if you need to have an installment, you can calculate that. We can also do some of that stuff on Finance Solver. The rules we need to make sure we're following when we're talking about payments and all that sort of stuff, especially when we're talking about Finance Solver, and what you can put in your summary book. But that was what I did before. What we're going to do is some worked examples. So we're going to be doing some worked examples that relate around the recurrence relationship and just starting to use the annuities formula here. So let's have a look. So just as a reminder, that's our recurrence relation. So Vn plus 1 equals Vnr minus D. And if I bring that up here in terms of my question, so this is work example 1. I've got my recurrence relation equation here. Remember, this is just the growth or compounding factor, which is big R, if you want to call it that. State the variables. Well, V0 is 100,000. 15 years, don't have to worry about it right at the moment. My R, remember, is 7.5 divided by 12. So it's the 7.5 is here, the 12 comes from its debited monthly. Okay, and I'm paying it back with monthly with 927 per installment. So D equals 927. Okay, so that equals 0.625. And what they're asking for is complete the table below for the first 5 repayments. So basically what they're asking you to do is go through that and calculate. So this would be 927, 927, 927. Oh, I said it loud and I still can't write it properly. 927, 927. All right, so this, remember, is your V0. This will be your V1, your V2. But remember, you're after your V1 here. This is V1, V2, V3, etc. Okay, that's what, oh, I should actually write it over here just so I give you, rather than put it there, it's going to put V1 equals V2 equals V3 equals, and I'll be using V3 there, V4. Can you see what I'm doing? I'm making the links as to how you should be, that'll give me V5. Okay, so when I calculate V1, now remember, I was showing you a way you can do this on your calculator, but if you calculate it, I'm just going to give you the value here. That would be 99698. That's my V1. Okay, so V1 I put here, so that's going to be 99648. Then I would do my calculation. I would be use a calculator. You can do this manually. Oops. You could do this manually if you want, use this equation manually, but I'd be doing it on the calculator. Okay, and if you have troubles doing that, come and ask me. And V2, I'm just going to do V2, and we can sort of you know what we're going for here. So V2 would give me 99394.11. Okay, and you get the hint that bang, that's going to go there. Bang, that's going to go there. Bang, that's going to go there. And you're going to get a value as well as V5. So those are the 5 you're after. Okay. So next question. Next question is using the annuities formula. So let's look at, let's go back and look at what the formula you need. This is the formula you need here. Vn equals V0 Rn minus D multiplied by R to the power of n minus 1 over R minus 1. And you'll see in a moment why I said previously this is messy. Not because, it can become messy when you have to write it and stuff. But let's just go with what we've got. List of variables. My loan, that's my V0. That's what I've borrowed. So 50,000. Okay. My D my monthly payments is here, is 358.22. You've got, in terms of here, I'm going to put my R. I'm going to go 6, but it's monthly, so divide by 12. I want to find the amount still owing after 10 years. What that means is I'm making monthly payments, so 12 payments a year for 10 years. So my number of payments is going to be 10 years times 12, because it's every month, 120. All right. So from my R, I can get my big R, which is going to be, remember, this is what you put in the calculator, 1 plus 0.5 over 100 will give me 1.005. Okay. I put all those values into this. So I'm going to draw it out. And this is why, this gets a little bit messy here. So I'm going to put in here, I'm going to go 50,000. And then I'm going to put 1.005, 120 minus, and that's I'm going to put D, I know what D is. D is 358.22. And you can see I underestimated a few things there. That's going to be 1.005, 120 minus 1. And then this is going to be 1.005 minus 1. Divide all that by that, and you do all that, and you'll get an answer. Now, that'll give you an answer of, you put that all in, you'll get V120 equals 32264.98. So amount owing after 10 years is 32264.98. Okay. This is why I say it's messy, because to do this part, that's what I mean by messy. I should have been a bit clearer when I said that. Just to put that in your calculator, you have to be very careful. And as you'll find, for questions like this, what we can start to actually use is the finance solver. But it's important to see that straight up, because if you don't, you won't know, what's been shown. So you need to be, you need to know where things are coming from. Okay. And probably what I should have shown here, and I sort of skipped that, I'll just quickly show you. It'd be Vn plus 1 equals Vn, and as you got in the brackets, it's 1 plus 0.625 over 100 minus 927. That's basically your formula. So it'd be Vn 1.00625 minus 927. That's what needs to go in your calculator when you calculate that out. Okay, so that's working those out. All right, that one would be annoying, that one, just in terms of making sure it's all correct. Next couple of worked examples. Okay, so in this one, what we're going to do is we look at, he wants to borrow 2,800 for a new sound system at 7.5% per annum, adjusted monthly. So what's the information we've got? We're borrowing 2,800, so that's V0. V0 equals 2,800. R 7.5. Is there any other things here? It's per annum, but interest adjusted monthly, so divide by 12. And that becomes to 0.625. All right, so that means our R, our big R, is 1 plus 0.625 over 100, and you can calculate that out. What else we've got here is N, our number of repayments. It's adjusted monthly, not just, so it's every month, and it's for 1.5 years. So we're going to have 18 repayments. Okay, so we could put that into our into the formula. So we could use so number one is, so to calculate one, I would use that equation there. Okay, or alternatively, I use Finance Solver. Okay, and the question is, what do I put in for Finance Solver? Oh well, here I've got Finance Solver up. So N is our number of repayments. We said that was 18. So let's put 18 in here. Okay, we said our interest was, I think, 7.5. Our principal value was principal value 2,800. 2,800. We're after payments, and we're going to have to sorry. We're after, so we're going to leave that. Our final value is, we want that is fully repaid, means final value is 0. I could have done it like that. That probably would have been easier. Fully paid means final value equals 0, or VN in terms of the equation equals 0. That's what the fully repaid means. Okay. So again, I could use that formula, or I could calculate it like this. And now I go payments, I go PMT, and I go. Now here's a point you need to be careful of. I want to borrow 2,800. I'm borrowing. If I'm borrowing, so it's a loan, I'm borrowing, my PV is going to be positive. And it means my payment should be negative because my FV, my final value, is 0. Okay, so if I go enter, what do I find? I find I've got the wrong answer for some reason. Oh, important point. It's 12 months. PPY is 12 months. Let's go back there. That's better. Yeah, so I just going through everything else, and I forgot the payments per year because it's per month, so it's 12 months. You know, it's 12 payments per year. Okay, so my payment says negative 164. That basically means, as I said before, the payments negative means I'm paying money to the bank. So that's the negative part there. So so if I go to 1, my number of payments, what was it, 164.95. So it's repayment is 164.95. Okay, that gives us that value there. So what would the total interest be charged? What would the total interest be? So I'm going to put 2 down here because I've run out of room up top. What it is the total interest. It's going to put total I for total interest equals total repayments, repay, subtracting how much I borrowed. Okay, because we're only looking at interest. We're sort of the total It's about how much I've paid, because remember, I'm paying $164.95 every month. That'll pay off my loan, but it also then will be the interest on top. So my total repayments would be 16495 times 18 minus 2800, and that'll give you an answer of 169 and 10 cents. Okay, so the total interest over 18 months on loan. Oops. Okay, so last worked example here. In this question, we want to find, we've got, as we said there, it's got Josh Burrows 12 grand for some office, home office equipment, V0. He agrees to repay the loan over 4 years with monthly installments. So from that, I know N is 4 times 12. That's my 12, that's my 4. And my little r is going to be 7.8 divided by 12. And how do we know that? Well, because 7.8 is monthly installments. So if you're going to use the annuity formula for this one, this is what you'd have to do. This would be, oops, I hate when I do that. This would be 0.65, okay? And therefore, if I was calculating R, it would be 1 plus 0.65 divided by 100 equals 1.0065. Now, here's the trick. So I've done all that, but what I really need here is N, which is 48. Now, I'm going to put this here. And what you'll notice is I can actually write 4 times 12 here. And I go to next one, it'll calculate it for me. In this case, my interest is 7.8. My V0 is 12,000. What are we after? The installment, that's the repayments. So I'm after that, so I'll come back to that. My final value, he agrees to repay the loan for 4 years. So my final value is going to be 0 again. Okay, final value 0. It's monthly repayment, so that's going to be 12. So I put my cursor back in there and I press enter. And what I get is 29183. So my installment value is 291.83. Okay, let's put it down here. So my repayments, monthly repay is $291.83. Okay. B is a slightly trickier type of question. And it says it to do it for the 10th repayment of the 40th. I'm just going to do it for the 10th because it's the same process for both. The trick in this one is you got to work out basically that difference between the 10th and the 9th, the 9th and the 10th. So you got to find the amount owing after 9 months. Okay. And so you can put that into your formula if you want. And you'll get a calculation where V9 equals a particular value. So what you can do, you can use your annuities formula, or you can use TVM Solver. And luckily for us, all of our, well, that was different, but I had to check something. That was the same. N is the only thing I've changed because everything else was the same. N is the 9th repayment, so I type in N up the top. My interest is the same. My PV is the same. My payments are 291.83 as from before. And what I do here, and because I've already calculated it, I just go enter there, and it shows me that V9 is 10,024 and 73 cents. If I put 10 up here, oops, so I put 10 there, and can go to FV because that's what I want to find out now. That's my VN. It's now 9738, 9798. Because clearly I can't read properly either. 9798 and 6 cents. Okay. Now, what you need to do is you're looking at the principal repaid in that, because what it was asking for is the principal and interest paid repaid, the principal repaid and interest paid during the 10th repayment. So going from the 9th to the 10th. Principal repaid is equal to 10,024. Hang on, I should be a bit clearer here. Oops. That's V9 minus V10, basically. So that's 10,024.73 minus 9768 and 6 cents. That's going to be 22667, and that's the principal repaid. So normally you'd want to do right at say in your 10th repayment, that was much the principal, how much, $226.67 that a principal was repaid, and the total, the interest paid, okay, is going to be the repayment, okay, minus the principal repaid. Okay, that will give me a value of so it's going to be 291.83 and minus 226.67. That gives me a value of $65.16. That's my interest paid. Okay, so there's 4 worked examples as a starting point to work through for the reducing balance loans. Okay.